The project overview of the cocktail machine by Adrian Heaton, Kayla Morgan, Keandrick Tyler, Hunter Brown, Ricky Gillette, and Bryson Glenn.
The motivation for our invention came from dealing with the hassle of having to find, pick up, and pour a drink into a cup. We wanted to make a machine to automate selecting and pouring a drink at the press of a touchscreen. The objective of our project was to create a machine that could house drinks while keeping them cold and allow for a user to receive a selected drink by choosing it on the touchscreen. We also wanted to make a way for the user to know how much of a certain drink was left.
Problem definition. In both commercial and residential applications, serving cocktails can cause a variety of issues. First off, breaking of the alcoholic container and spillages when mixing the drinks. Second, dilution of the beverage due to ice being added to the drink in order to cool it. Third, inconsistent proportions of beverages, this one being more applicable in the commercial setting.
As you can see here, this is a circuit diagram for a system. Going from left to right, we have the touchscreen, the master Raspberry Pi Pico, and then which is also connected to a Raspberry Pi Slave Pico, and then it's connected to the HX711, which is what we use for our load cells, and we also have the relay board connected to the Raspberry Pi Slave Pico. This right here is the block diagram and flowchart for our system. Starting with the block diagram on the left, we have the touchscreen display, which talks back and forth with the master Pico, and then that master Pico talks back and forth with the Raspberry Pi, the Slave Pico, and that Slave Pico pretty much operates the relay board, which connects to the valves, and then it also talks to the load cells with the analog digital converter in between.
The master Pico is responsible for operating the touchscreen, providing the user interface for the project. On startup, the screen displays a loading background while initializing UART and assembling the display frames for later use. Once the preliminary tasks are complete, the main menu is displayed and the touchscreen begins accepting input from the user. From the main menu, two buttons allow the user to view the liquid levels in the jars or move to the drink selection menu. If the user selects the status button, the master Pico sends commands to the slave Pico requesting the liquid fill level. The results are then displayed on the screen. If the user selects the drink selection button, the drink menu with 9 options are shown on the screen. When the user pushes an option, a command is sent to the slave Pico corresponding to the selection. The slave Pico is responsible for listening for and fulfilling commands sent from the master Pico. On startup, the slave Pico awaits commands from the master Pico. Once a command is received, the request is fulfilled. If the master Pico requests the fill level of a liquid, the slave Pico reads the value from the corresponding HX711 ADC and calculates the fill level before transmitting the fill has a value between 0 to 100 through UART. If the master Pico requests a drink, the slave Pico opens and closes the necessary valves before sending an acknowledgement byte indicating the sequence is completed. The slave Pico then awaits for the next command to be sent.
We utilized a relay that consisted of 10 input pins, 1 for each of the 8 switches, 1 for the voltage, and 1 for the ground. On the output side, the 8 switches had a common wire conducting the 12-volt supply. Each switch had a wire going to a singular solenoid valve that would send the on or off signal. The system used 8 solenoid valves controlled by the 12 volts supplied from the relay. The valves were normally closed, allowing us to control the flow of selected drink by opening a singular valve. These 8 pathways allow the machine to control which liquids leave the pressurized container housings within the fridge.
Load cell subsystem. The load cell subsystem worked by having 6 individual load cells all connected to their own HX711 chip. You can see on the picture on the right, each mason jar has the wires from the load cell coming and meeting to the back of the board, which is the picture on the left, where they're all connected to the HX711 chip. The HX711 chip contained an ADC that would send the output from the load cell to the Pico. The HX711s all shared a clock, but they had their own respective data line.
Strengths and weaknesses of the cocktail machine. The strengths: the correct drink would dispense based off the selection on the touchscreen. The drink would dispense fast and efficiently, and in the system there were no liquid leaks. And the housing was 3D printed and is very durable. And for weaknesses, we have minimal air leakage in the manifold system, and the load cells would suffer from drifting because we have no way of zeroing out the system based off the design, and the touchscreen sensitivity is rather low, and sometimes it takes a second for the touchscreen to pick up the user input. The performance analysis of the system performed as needed, meaning that the correct drinks were made based off the touchscreen. The load cells displayed the status of the jars based on the percentage full, and the valves open and closed based off timing. There were no liquid leaks in the system. The system did everything we needed it to as intended, and the only downside is that there are minor air leaks and load cell drifting, which the air leaks are controllable, but the cell drifting is not, because we don't have a way to zero out the load cells.
We faced 6 significant challenges. The first challenge was sealing the tubes. We went from using silicone, super glue, and finally using a combination of the two with cable glands to tighten the seal on the top of the mason jars with the tubes to keep from having liquid leakage. The next challenge was programming the load cells. Because of the load cells we used, we had difficulty calibrating them. This was mainly due to the lack of information found about them. We couldn't find the libraries for them, which made it hard to obtain precise weight values. The third challenge was designing the mounting brackets for the load cells. The fourth was designing the supply housing on the top of the fridge, which is meant for the funnel and the tubes to run the drink through and also hold the touchscreen in place. And the fifth was the PCB. Last but not least was the air leakage. There was pressure issues. For future directions, we plan to incorporate 3 fundamental changes. The first change would be to be able to have more drinks, which would render more drink combinations. The next change would be more precise sensors as for load cells, since they pose many issues, which was discussed in the challenge section of this video. And the last would be better supply housing for the drink funnel, the touchscreen, and better mounting brackets for the load cells.
Yeah, it's trying to turn right now.
What'd you do?
There's nothing running on this.
So the plan
That one was rapidly switching.
Yo, is that thing still like